Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with the same module, that is Procedural Programming module. In the last class we have finished with chapter number 15, that is the miscellaneous features available in C language. Now I'm going to start with the next topic, that is chapter number 16, that is C under Windows. But before this, let's take a quick review what we have covered in the last class. So let's take a quick review. In the last class we have discussed or we talked about union. That is, what is a union, what are the types of union, and why we are using the unions. And what is the main difference between structure and union. So we have covered the structure in the 7th chapter or 8th chapter. Now this is a miscellaneous feature that is available in C, that is a union. So this is the same derived data type. That means a union is same as a structure, but the main difference is that whenever we use the union, all the members of the variable, that is all the members share the same memory location. That is every member shares the same memory location. That is, in structure every member got the different space in the memory, but in this the same space is occupied by different members. So this is the main reason, or this is the main difference. Then we have discussed about the union. That is, union is a way to differently denote the multiple tasks that is used for the multiple systems. So this says a union offers a way for a section of memory to be treated as a variable of one type on one occasion and as a different variable of different type on another occasion. That is, we can define any n number of variables, n number of data type variables, for example int, float, n number in the memory, and we can use it for the sake of simplicity, for the sake of union, for the sake of complexity. We are using the union. This is the example how union can be used, and this is a way the structure is used. In the same way union is used. We have studied that is union A. There is a curly braces. Then there are two types of data types, that is int I, char ch2. Int I means I is a variable that is of integer type. Ch2 is also a variable that is of character type. But ch is an array that contains two values, that is 0 and 1. So union name is A, that contains two data types, that is int and char, and then union is closed by using a semicolon. So this is the example that we have discussed, and this is a diagrammatical representation how union can be used. So this is this takes 1 byte, 1002, 1003. So this takes 2 bytes, that is a 1002, and 1003, 1004, 1005. Okay, okay. Awesome. So why this is 1002, 1003? Because the int takes 2 bytes. So 1002 and 1003 is reserved for only the integer value. But for the next one, that is CS0, there is only 1 byte, and next one there is only 1 byte. Why? Because the main reason is that we are using the union, and the ch variable is of integer data type, or ch0 is of character type, so it takes 1 each. That is one data type or 1 byte each. Then this is an example that we have discussed. That is, now we can declare a similar data type, but instead of using a structure we can use a union. So instead of using a structure we can use the union, and this is the variable of the union. The name of the union is A, and the data variable name is key. So key is a variable of the union A. Then this is representation of the union. This is a representation how union will be represented. The same memory location will be shared by multiple variables. That is, the same memory location is shared. In structure there are different memory locations, but in this there is the same memory location, and that will be shared by different members of the union. Then we have discussed this is a diagrammatical representation. Then we have discussed how it will be used and what is the benefit and how the variable will be declared. This is the example how the variable will be declared. This is a diagrammatical representation. That is, first of all, it is converted into 16 bits. Why 16 bits? Because it takes 8 bits and sorry, it takes 2 bytes and 1 byte is equals to 8 bits. So 2 byte means 16 bits. So that is a 16. Then we have discussed this is a low byte and this is a high byte. Yeah, one important thing that we discussed, that in C language or any language, this is a by default that first of all low bits will be covered up and then only the high bits will be covered up. That will be used. Then we have discussed about next thing, that is example, that is how the union will be used. After this we have discussed one practical approach on the union, that is how union will be used and why union or why we are using the unions. For Larry, if you want, when Olesam has go or will go, then I will discuss the practical part again if you need for the union. Alright. And then we will discuss about the union of structures, that is how we are using the structure or union within the structure. That is also the main part, that how we are using the structure within the union or union within the structure. This is the best example. This is the example. Olesam, can you explain this example to me? Olesam, can you explain this example, because I've explained this example to you. Now this is a Larry, because Larry has not come yesterday. First of all, why Larry you have not come yesterday? What's the reason? Where were you? Yeah. Yes, sure, sure. Okay. Okay, okay, okay. Now, Olesam, can you explain this example? Yes, Olesam. I think Olesam is not on the line. No issues. So, Larry, my question is to you. Can I repeat the practical approach of the union? Okay, because I don't know where is the Olesam. If Olesam will go somewhere, because I think Olesam will go for a minutes, uh, then it's okay. Otherwise, I will repeat in the next session or next session. Let's see. So this is the example. This is the void main, and this is the structure. The name of the structure is A, and there are two data type variable is declared. What are the two types? That is int and the char. Int is of 2 bytes and char is of 1 byte, and C2 means this is using the 2 bytes. That is int takes 2 bytes, and for char C0 takes 1 byte and C1 takes 1 byte, because it is of char and it is of 1 byte each. So this means this structure takes 2 bytes for the integer and 2 bytes for the character. Then next structure is declared, that is a structure B, that has also a two types, that is int j and the char d2. Int takes 2 bytes in memory and char takes 2 bytes in memory. Why 2 bytes? Because for D there is a char for 1 byte is reserved for the D0 and another byte is reserved for the D1. So there are two parts. Right. Then we have declared the union. So there are two structures, structure A and structure B. There is a union declared, that is a union name is Z. Right. In this we have declared the variable of the structure. First of all, we have declared the structure variable, that is struct A key. That means it is a variable of the structure A. So name of the structure is A, that we have declared in the upper section. Then in the next section we have declared about next one, that is struct B data. So key is a variable of the structure A and data is a variable of the structure B. So there are two types. Then we have declared the variable of the union Z. So this is the union. In this we have declared the two variables, that is of one structure, one structure. Now I have declared, or we have declared the one variable that is of union Z. So union Z is a name of the union is Z, and that have a data type, or that have a variable that is a stage. So stage is a variable that is of union Z, right? Then uses the dot operator. Why we are using the dot operator? As I told you, in structure and union we have to use the dot operator for accessing the elements. Now I have to access the elements of the structure, but structures variable are defined in the union, so they are related with each other, that is structure and union. So I have to use the first of all variable of the union, then I have to take the variable of the structure, and then I have to take the element of the structure, that is strange dot key dot I. This strange is a key variable of the union. Then there is a dot operator, and then there is a dot operator again, and that will be accessed by the I, or that will be used by the I, that is strange dot key dot I, right? That is equals to the 512, that is I takes the value of the 512. Then another part is strange dot data dot D0, that is at the first location, that is at the D0 it is 0, at the D1 it is 32. So this is the way how we access the elements of the structure, and this structure is defined, or the variable of the structures are defined in the union. So this is the way how we are using this one, right? Then we have to print up the values of the different union, that is these are the various elements, these are the various values. So first one is strange dot key dot I, this is a value 512, right? Now strange dot data dot J, so this is the structure of the B, that is a part of the B. So this is strange dot data dot J. Then strange dot data dot C0, that is at the C0 location. This is the C0 and C1, and the C0 what is the output, and D0 what is the output, C1 what is the output, D1 what is the output. Now this is the output. At the strange dot key dot I there is a 512. In the same way, strange dot data dot J, that is also value of 512, and at the C0 there is a 0, D0 there is a 0, C1 there is a 32, D1 there is a 32. So these are the different values that is used over here. Then just as we do with nested structure, we can also access the elements of the union in the program using dot operator twice. As I told you, whenever we have to access the elements of the structure and union both, then we have to use the two dot operator. One is for the structure and one is for the union. So this is the concept how we are using this one. Now then we have discussed what is the utility of union, that is why we are using the union, what is the benefit of union. The main benefit is that we can or union provides a facilities to store information about a information, or store information about a thing. There are different information, let's say example. So we have storing the different information in only of different information of a single object. That is, there are multiple information, multiple type information, and that information will be stored in only one object, and that object will be shared by multiple variables. That is the main utility. This says, suppose we wish to store the information about the employees in an organization. That is, my requirement is to store the information about the employees. That is, what are the information? That is a name, grade, age, and we have to check the condition. If it is highly skilled, then hobbies name, credit card number. If it is semi-skilled, then vehicle number. So we have to gather, or we have to clutter about different dissimilar networks. So that will be provided by the union. That is, multiple dissimilar networks or multiple dissimilar types are used within this one. Then this is an example that we have discussed. This is the structure employee. This is the struct employee. This is the structure info 1. So this is an example how we are able to gather the information about employee. One is the variable of character, that is a n, that takes 20 value. That takes 20 value, and char grade, that is a 4, int age, that is of age, one hobby, one credit card number, one vehicle number. Then dist, one is a district. Then we have discussed about the volatile. This is example. This is example of the structure and the union. Then we have discussed about the last topic, that is what is a volatile qualifier. So this is just to optimize the code that contains the variable. We use the variable that is located from memory into the register. That is, when we are using the volatile, the variables or the data will be stored in the registers, not in the memory. That is, it is gone from the memory and it is stored in the register. So this is a type how we can declare a volatile variable. This is volatile int j. That is a volatile, and there is a int and there is a j. Another place where we may want to declare a variable is when the variable is not within the control. That is, if the variable is beyond the control, in that situation also we can use the volatile quantifier. This is the next part is your summary. This is the most important part. This I left for the today's class. The first point says the enumerated data type and the typed up declaration add to the clarity of the program. Remember, what is the enumerated data type? That means we are giving the variables, and the first, if I am using the enumerated data type, whatever the variables is declared in enumerated data type, the first variable has a value 0 and next variable has a value 1, and so on it goes till the n number of variables. Right. So this is the enumerated data type, and we have declared the type def. So we have to declare the type def for changing the data type. Suppose I have declared the type def int Harry. Now I am using the Harry because why? The name of the int will be changed to the Harry. Now if I have to declare the variable, then I have to use Harry A, Harry B. That is, A and B are the variable that is of integer type. But now I do not take int. Instead of int, I have to take the Harry because I have to type def, or I have used the type def for the Harry. Then second point says typecasting makes the data type conversion for specific operations. Remember, typecasting is used for converting one data type into another. This is also a main requirement for the system, that is how to use the typecasting. Whenever we have to change the variable, this can be used for typecasting, that is changing the one variable into the another variable. Next point says when information to be stored can be represented using a few bits of bytes, we can use a bit fields to pack more information in a byte. That is, whenever we use few bits of bytes, that is whenever we use small amount of data, then we use the bit fields for storing the data so that it can be packed, or the information will be packed in a byte. So these are the three topics, important topics that we have discussed. One is type def, one is typecasting, one is type def, one is enumerated data type. Next part is D part says every C function has an address that can be stored in a pointer to a function. That is, this chapter also contains one topic, that is a pointer to a function. That is, we are using the pointer within the function, and there is also a capability to return the pointer within the function. So this is also a capability that the function can also return the pointer variables or pointer values. Next point says we can write a function that receives a variable number of arguments. That is also one topic that we have discussed, that is a function with variable number of arguments. That is, we can give multiple arguments within the parenthesis of a single function. Last point says union permits access to some same memory location in multiple ways. That is, there is the same memory location, we have to use the same memory location, and that same memory location will be shared by multiple variables of the union. Then these are the various, this is a summary of this chapter. These are the various questions. Now let's discuss about this question. First of all, the first question says, what will be the output of the following program? That is, what is the output of the following program? There is a void main. There is a enum status. That is a status is a variable name that is of data type enumerators that has a values pass, fail, al, kt, that is at, kt. Then enumerator status that has three variables, that is std, 1, 2, 3. Then we have pass, or we have initialized the value of pass to the stud1, fail to the stud2, akt or atkt to the stud3. Now there is a printf statement for printing three values, that is stud1, stud2, stud3. Now what is the output? So in simple terms, the output will be 0, 1, 2. Why? Because stud is a 0, stud2 is a 1, and stud3 is a 2. So these are the values that starting from 0, 1, 2. So this is the output. Then second question is, this is the example of the typecasting, or typecasting, that is converting one data type into the another data type. So this, what will the output? First of all, it is of integer, that is it gives the integer that must be converted into float, and that gives the value by using the printf, that is %f. Now this is the void main, that is float ij, then uses the I, that is a float value will come, that is 2 by 3 by 2, that is 1.5. This is I has a value, that is a 1.5. Now this 1.5 is multiplied by the 3, that will become 4.5. So this is the output. Now this j is converted into the int, so the output will be 4. Why not 4.5? Because this will be converted into int, so this 4.5 will be automatically converted into next part, automatically converted into 4. So this is the way how it will be converted into the 4. And then this is the next example. This is the next part, that is pick out the error if any in the program. So these are the various questions, that is pick up the error. This is the A part, this is the B part, this is the C part. This is next, this is next. Then attempt the following. These are the various questions, that is attempt the following questions. Now let's continue with the practical approach for Larry. Alasam, are you able to hear me? Alasam, are you able to hear me? I think Alasam is not here, so I'm again doing the practical approach for the Larry, so that your concepts are clear. Larry, are you able to hear me? Okay, so let's do the practical approach. Basically the program has already been built, so there is no more time, or there is no more time wasted for writing the program. So I have to open the file of a union. This is the union. So this is the example of the union. First of all, the two header files are included, that is stdio.h and the conio.h, right? Then there is a void main, then there is a union that is declared, that has a name, or that has a union name is result, and there are three data type, or there are three different datas, or there are three different values. One is sum, that is of double, one is marks, that is of int, one is grade, that is of char. So these are the various types. Then this means if we are using the union, the largest memory location will be used. If I am using the double, so this takes 8 bytes in memory, that is union size is 8 bytes. Why? Because double take 8 bytes, int takes 2 bytes, char takes 1 byte. So what is the maximum size out of these? That is a 8 byte. So this 8 byte will be reserved for the union. So if I printf the size of the structure or size of the union, this will be taken as a 8 byte. Why 8 byte? Because it takes the maximum data type value. So this is the union that is declared. There is a semicolon that will be closing the that will be used for closing the union. Then again using the structure, that is declare the structure that has a data type result, that is for example res. Then in this there are three types of data that we are using, that is int age, char name 15. Name 15 means from 0 to 14 it has the values. Then in the structure I have to declare, or I am declaring the union result, that is union result pref, that is result. We have declared the variable of the union result, that is result is the name of the union, and I have to use the variable of the this one, that is union result pref. So pref is the variable that is used for the union result. Now this data, this data is a variable of the structure. This is the variable of the union pref, and this is the variable of the structure. Now uses the clear screen for clear the screen. Then uses the printf statement, that is size of union. That is what is the size of union? That is percentage %d. That is the size will be measured in terms of discrete value. Then uses the size of operator. So this is the size of operator. Then there is a data dot pref, that is the data dot pref. This is the data, that is a structure variable. This will be used with the dot operator, and that uses the pref. So pref is the variable, that is data dot pref. Then uses the printf, that is size of structure percentage %d, that is size of data. So this data dot pref will give the value, or will give the output of the union, that is how much union will take. Why? Because pref is a variable of the union. And then size of data gives the size of the structure, because this data is a variable of the structure. Now let's see, if I compile this code, there is success. If I execute this code, this is the size of the union, that is 8, and size of the structure, that is 25. Now let's see, remember 8 and 25. So this is the double that takes 8 values in the memory. That's why I told you in the starting, that is whatever the largest size of the data type, that is the maximum size of the union that can take place. That is, this is the 8, union takes 8 bytes. Now after using the union, so this line takes 8 bytes, right? Now this is a 2 bytes, 8 plus 2 is 10, this is the char, this takes 15 bytes. So this is 2, this is 15, that is 17, 17 plus 8, that is your 25. That's why the output is 25. So this is 8 and this is 25. Larry, this program is clear to you? Clear? Okay, good. Yes, yes. Then we have also declared one more in the last class, that is size of, I think. No, this is already done. Even note, nothing. Type def, nothing. Suffix, nothing. Prefix हो गया, arrays. This is used for calculating the average and the sum. This is what you have covered. This one means you have studied this one. So let's start with the chapter number 16, that is C under Windows. So let's take a starting point and then come to the practical approach. Today I'm going to start with the practical approach of the functions, array, because there are so many topics that have left, because we have not discussed the practical approach in the that time when we have discussed about the arrays and structure. So that is the main point. So let's start with the chapter number 16. Now, there are different topics of this chapter. That is, first topic is like which windows, that is which windows is used with the C language. Then what are the integers, heavy use of the type def, then size of the pointers, DOS programming model, Windows programming model. This means what is the DOS, that is disk operating system. Then Windows programming model, event driven model, Windows programming, a closer look, that is how we are using the Windows programming. Then first Windows program, how we are using the Windows program. Then Hungarian notation, then role of a message box. Now here comes a window, that is a basic idea of the window. Then more windows, real world window, creation and display of window, interaction with window, reacting to messages, program instances, then there is a summary, then there is a exercise. So these are the different topics that is available in the this one, that is a C unders window, that is a 16th chapter. Now this is the same, which window and so on, so on, so on. So this is so far we have learned every single keyword, operator and instruction that is available in C. That is, so far we have discussed the keyword, operator and the instruction that is available in C. Therefore, we are through with the language element that were then to learn. That is, there we were through with the language element. That is, we are able to get the language element that we are taken to learn. We did all this learning by compiling our programs using a 16-bit compiler. That is, we are using or we are comparing the programs for compiling using a 16-bit compiler like Turbo C or C++. Now, it is a time to move on to the serious stuff. Means it is a time to move to the next part, that is the serious stuff. To make a beginning, one has to take a very important decision. Should we attempt to build programs that are targeted towards 16-bit environment? That is, this theory says which window will be used for the C language, whether it may be 16-bit, whether it may be 32-bit. So it depends on the requirement to requirement how it will be using the programs. Then next line says there is a different provision, that is the 32-bit environment like Windows, Linux. Obviously, we should choose the 32-bit platform because this is what is commercially used today and would remain so until 64-bit environment takes over in future. That is, this is the way how it will be used. This is a 64-bit and there is a 32-bit. That raises a very important question. It is fertile or futile to learn C programming using 16-bit compiler like Turbo C or C++. That is, whenever we learn the C programming, either I should the 16-bit compiler or either we should use the 32-bit compiler. Absolutely not. The typical 32-bit environment offers so many features that the beginner is likely to feel lost. That is, if I am using the 32-bit compiler, there is no standard way or there is no way to use that because this is not for the beginner level. If I compare with the 16-bit compiler, that offers a very simple environment that has a novice but master quickly. That is, if I'm a beginner programmer, that if I'm using or if I'm used if I use 32-bit, so there is a difficulty for using or there difficulty for getting that one. Why? Because there is a less friendly or that is less user friendly. So instead, if I am using the 16-bit compiler, that is very simple environment, and then we can access or we are able to get that one very efficiently or quickly. Note that the C fundamental are out of the way and you are confident about the language features. That is, we have covered so many features of the C programming or C fundamentals, right? That is out of the way and you are confident about the language feature. That is a time. So it is a time for us to delve into the modern 32-bit operating environment. That is, now it is the time to deal with the or to go into the next part. That is how to generate the or how to use the 32-bit environment like Windows and Linux. In this chapter, we would explore how C programming is done under Windows. That is how we are able to do the C programming in the Windows. That is, this chapter covers how C under the Windows. Right. Chapter 20 and 21. So this is chapter number 16. So after this, there is a chapter number 20 and 21 that are devoted to exploring C under Linux. That is how to use the C under the Linux. Now, next question arises, which windows? That is, which window will be used for this one? And then this says, to a common user, the difference among various versions of Windows like Windows 9.95, 98, ME, NT, 2000, XP, Server 2003 is limited to only visual appearances. That is, these are the various outdated window. If I say these are the various outdated windows that only gives the visual appearance, that only gives the attractive look for the user, but they are not able to get the various features like desktop, taskbar, program menu, and so on. Things like color of the title bar, shape of the buttons, desktop, taskbar, program menu, etc. But the fact is that it is much further than that. Architecturally, there are huge differences among them. So many other differences that Microsoft categorizes the different versions under two major heads, that is consumer Windows and Windows NT family. So in simple terms, this is the theoretical chapter. This says we are using the Windows for the C programming, or we are using the Windows for the C, we have done the programming in the C Windows, or we are able to do the programming in the Windows also. So Windows 95, 98, ME fall under the consumer Windows. That is, these are the windows that is covered under the consumer Windows, whereas Windows NT, 2000, XP, Server 2003 falls under the Windows NT family. So there are different categories: Windows 95, 98, ME. These are the categories of the consumer Windows, while these are the categories of the Windows NT family. This says consumer Windows was targeted towards the home or small offices users. That is, whenever we have to use the Windows 95, 85, that are basically targeted to the next part, or that are basically targeted to the few parts or the less part, that is the use in home offices, whereas NT was targeted towards business offices. That is, business users will use the Windows NT family, which is the Windows NT family, that is 2000 XP Server 2003. But for home, for basic operations, the Windows 95, 98 is a better one, or cool one. That is, there is no other requirement for the Windows. Microsoft no longer provides support for consumer Windows. That is, Microsoft is not provide the support for the Windows 95, 98, ME. Windows Microsoft does not support. Hence, in this book, we would concentrate only on the NT family Windows. So this is the main crux. So this paragraph says there are two parts of division. One is consumer Windows, that includes Windows 95, 98, ME. One is Windows NT family, that includes 2000, XP, Server 2003. So these are the various categories, but Microsoft does not support the consumer Windows. Hence, in this book, we would concentrate only on the NT family Windows. So in the rest of this book, whenever I refers to Windows, I mean Windows NT family, unless explicitly specified. Before we start writing C programs under Windows, let us first see some of the changes that has happened under Windows environment. That is, what are the changes that is made under Windows environment. This is, first of all, first change is your integers. Under 16-bit environment, the size of the integer is of 2 byte. That is, if I am using the 16-bit, the size of the integer is of 2 byte. As against this, under 32-bit environment, that is, if I am using the 16-bit, there is a int takes 2 bytes, and if I am using the 32-bit, the int takes 4 bytes. This is the main difference about the integer. And then next point says The range is also different, that is 16 bit have a different range, that is minus 32767 to 32767, but this one has a different range, that is 32 bit has a different range, that is minus 21474 and so on to 214748367. Therefore there is no difference between an integer and long int. But what we if we wish to store the age of a person in an integer? That is how we can store the age of an integer or age of a person in an integer. It would be improper to sacrifice a 4-bit integer when we know that the number to be stored is hardly going to exceed 100. That is, the age is not 100 more than 100 of any person. So I'm using the 4 bytes? That is, 4 bytes means 4 into 8, 32 bits. So why I waste 4 bytes or 32 bits for simply storing the name of the or simply storing the age of a person? In such a case, it would be more sensible to use a short int since it is only 2 byte long. That is, in case of this one, uses the short int under 32-bit version, 32-bit environment, because that takes only 2 bytes long, or that is of only 2 bytes. Then the use of the type def. That what is the use of the type def? Now let us take a look of the following declaration. This is the color reference color. This is the handle H, V per W param W, L param L, bool B, are color free handle etc. New data types have been applied in C under Windows compiler. So these are the few new data types that is available under a 32-bit operating system that is used. One is color reference handle W param L param bool. So these are the new data types that can be added in the C under Windows compiler. Not at all, they are merely type def of the normal integer data type. A typical C under Windows program would contain several such type defs. There are two reasons why Windows-based C programs heavily use of the type def. That is, what is the main reason why mostly C programs using the type def? So this is the continuation of the 32-bit operating system. That if I'm using the 32-bit operating system, what is the advantage and why we are using this one? This says a typical window program is required to perform several complex tasks. That is, what is the use or what are the two ways or what are the two reasons why window-based C programs heavily make use of the type def? The first point is a typical Windows program is required to perform several complex programs. That is, if I'm using a typical typical Windows program that is also required to perform different complex tasks. For example, a program may print documents, send email, perform input-output, manage multiple threads, of execution, draw in the window, play sound files, perform operations over the network, apart from the normal processing task. That is, it is using the various threads, it is using the various programming, it is using the various conditions. Naturally, a program that carries out so many tasks would be big in size. That is, automatically that size would be big. At several places in Windows programming, we are required to gather and work with dissimilar but interrelated data. This can be done using a structure. That is how we are gathering the dissimilar data that can be done by using the structure. But when we define any structure variable, we are required to proceed with the keyword struct. That is, struct is the keyword that is used for the structure. This can be avoided by using the type def as shown below. This is the struct rect. This is the rect. There is a different data types or different variables. One is a top, that is also of integer type. Left, right, bottom. These are of integer types. And this structure will be closed by using the semicolon. Then there is a type def, struct, rect, rect. So this is the structure rect. This type def will be used. That means in place of struct rect, I am using the capital RECT. and in place of struct rect pointer I'm using the pointer that is prect. So these are the various type def for converting the or for transferring the data type from one part to the another part. This is the rect r. Now I am declaring the variables of the rect r, prect, pr. What have we achieved out of this? It makes user-defined data type like structure look, act and behave similar to the standard data types like integer, float, etc. You would agree that the following declaration are more logical than this one. This is more logical. Why? Because I'm using simply rect r int I. Instead of using the struct, I'm using this one. Imagine a condition where each programmer type def the integer to represent a color in different ways. That is type def int col, type def int color, color, color reference. To avoid this, choose multiple. Microsoft has several type def for commonly required entities in Windows programming. That is, there is a predefined type that is available in the Windows programming. Or these have been stored in the header files. That is, type def have been stored in the header files. These header files are provided as a part of the 32-bit compiler like Visual C++. Now, the next part is pointers. That is how how pointers are represented in a 32-bit environment. That is how pointers are used in a 32-bit environment. First of all, we have discussed about this one, that is a 32-bit environment, Windows 32-bit environment, 32-bit operating system. Then how we are using, or what is the use of, or how we can use the pointers in 32-bit and world. So before moving to this one, let's take a break. Sorry, let's take a break, then come back, starting with this chapter, that is pointers in 32-bit world. So let's take a break first of all. Back from the break, let's start with the session. Till now we have covered what is the difference between 16-bit operating system and what is the difference between 16-bit operating system and 32-bit operating system, and what are the features available in 32-bit operating system. Till now we have covered how integers are represented in 16-bit operating system. Now the next part is how pointers are used in, or what is the usage of pointers in 32-bit operating system. So this says in a 16-bit world like MS-DOS, we could run only one application at a time. If we were to run another program, we were required to terminate the first one before launching the second. That is, that provides a provision, that is, we are able to use only one program at a same time. That is, at the same time. But if we are using the 32-bit operating system, more than one programs are executed at the same time. That is a single tasking environment, since only one program can run at a given resource of the machine, like memory and hardware device. Under 32-bit operating system, like Windows, several programs. So example, this you got it. One is 16-bit operating system. For example, is MS-DOS, that is disk operating system, and MS is Microsoft. While the 32-bit operating system, the example is your Windows, like Windows. Several programs resides and work in memory at the same time. That is, more than one programs are residing and work in memory at the same time. That is, we are dealing with more than one program at the same time. Hence, it is known as multitasking environment. That is, more than one task are performed at the same time. But the moment there are multiple programs running in memory, there is a possibility of conflict if two programs simultaneously access the machine resource. That is, there is also a conflict whenever we are using the two programs, or two programs are simultaneously accessing the machine resource. So that is also a limitation, or that is also a foundation, because if they are accessing the same resource, then there is a conflict of accessing the machine resources. To prevent this, Windows does not permit any application direct access to any machine resource. To channelize the access without resulting into conflict between applications, several new mechanisms were created in the microprocessor and operating system. That is, new processing or there are new mechanisms, new methods were created in the microprocessor and the operating system. This had a direct bearing on the way the application programs are created. This is not the Windows OS book. So we would restrict our discussion about the new mechanisms that have been introduced in Windows to topics that are related to C programming. These topics are memory management and device access. So these are the various topics that is introduced, how to manage the memory in the 32-bit operating system and how to manage the memory in or how to access the devices in 32-bit and 16-bit and how to manage the memory in 32-bit and 62-bit uh, operating system. So this is the example. But I think this I will discuss in the next class, that is in the Monday's class. But I have to go through the practical approach today because practical approach is more important, right? So let's start with the practical approach. Now I'm starting or I'm doing only the basic example so that your concepts are clear, right? I think your concepts are not clear due to the data type, int, char, and so on. So first of all, let's take a basic operation or basic program of the C programming. First of all, the same header file, that is hash include stdir.h. In the same way, hash include conio.h. Now there is a void main, then there is a curly braces. Now uses the two variable, one is of integer, for example x that has a value 2, then for example float y that has a value again 2, the same value, then uses the clear screen, then uses the printf statement for printing the values or simple printing the size of the int or size of the uh, x or size of the integer, that is how many size it takes. So this is the percentage d bytes, for example. Then uses the size of operator for printing the size, then again uses the printf for printing the size of the float. This is percentage f bytes, that is size of y, then using the get ch, this is the example. uh, there is a void main, there is a two variable that is declared, one is of integer type, another one is of float type, both have a value 2, that is x has a value 2, y Hello, 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 hello. Yeah, is that audible to you? Okay, Larry, this program is clear to you, what I discussed by using the size of operator? Okay, and what about Olesam? This is clear to you? Yes, Olesam, this is clear to you? Okay, all right. Now, I'm moving to the next part, to the next program. Now, let's see. Simple if I'm using say similar program or new program. For example, if I'm using hash include stdi.h, then I'm including, that is hash include, that is conio.h, then uses the void main, then simply uses the clear screen for clearing the screen because there is no data type that is declared. Now simply uses the printf statement, then uses the result equals to percentage d, then this is enclosed. Now this is the main point. Check the condition over here only. If 2 is equals to 3, then there is a question mark. Print the value of 4, otherwise print the value of 5 by using the colon. Then there is a semicolon after this one. Now what is the output? I have to introduce the getch if I want. There is success. If I compile this code, with the result is 5. This is the output. That is, this is the condition. That is, if 2 is equals to 3, that is, it check the condition. This double equals to is used for the equality. That is, if it is equals to 3, that is 2 is equals to 2, 3 is equals to 3, then prints the value 4, otherwise prints the value 5. So this output is not correct. Why? Because 2 is not equals to 3, but 3 is equals to 3 or 2 is equals to 2. This is incorrect, so the output displayed is 5. Why? Because this is incorrect. This is an example that shows how this comparison will be done by using the double equals to, that is double dot or double equals to. So this is again the basic program. This is known as conditional operator. Which operator? Conditional operator. So I am giving the name. The name of the program is conditional operator. This question mark is known as conditional operator. This is conditional operator, right? So this is the next program. Any doubt in this program? This means if this is true, then this will be printed, otherwise this will be printed. Then means this will be represented by question mark. And this is the equality sign, this is the comparison sign. Any doubt anyone in this program? Hello? Yeah? Any doubts? Yeah? Yeah, tell me. Yeah, tell me, my voice is audible to you? Yeah, this is only to find out or how to use the conditional operator. How to use the question mark whenever there is a requirement of using the conditional operator. This is only example of conditional operator, nothing else. Is that clear, Oleson? Okay. Now let's move to the next part. Now I'm using the bitwise operator or the logical operators, how we are using the logical operator, bitwise operator, and what is the use of functions, how we are using the functions, how we are declaring the functions, then what is the usage of functions. Now let's see. Now there is a program for the string. Now if I open this one, sorry, I have to use the new one. Suppose I'm using the string in this program, like string means collection of characters. This is the void main, till this is the void main. Now I have to print or I have to use the char, that is char, this is the array variable. For example, if I'm using nm, that has a value 20, then using the int, that is has a value l, then there is a clr, scr, then printf, enter the string, then scanf, percentage s. This is the most important point, that is string is always represented by the percentage s. This is percentage s. Then there is a variable name, that is a nm. Now if I have to use the function, so suppose I have taken the variable as l, then simply use l is equals to printf, that is num, that is simply prints the value of, simply uses the printf for printing the value of num. Now if I want to calculate the length of the nm, that is what is the length, as I know this is a 20 characters, but if I have to print, then simply use length equals to percentage t. This is for example L, right? Now if I execute this code by using getch, now let's see what is the output. There is no error, there is a success. Now enter the string. Suppose I enters the string as Larry, for example. The Larry length is 5. Why? Because Larry, there are 5 characters. Now if I again compile this code and if I give the value or give the string as a Harry, this is also the same. If I use the sunflower, there is 1 2 3 4 5 6 7 8 9 characters, so sunflower length is 9. So this is the length, this is the sunflower, that is also printed and that is also used for calculating the length, that is the L. So this is a simple program that shows how to use the character array and how to use the percentage s for the string and how to use the printf function and store the value of printf into next variable and how to print the length of the one variable. This program is clear to all of you? Hello, yeah, this program is clear to all of you? Okay, thanks. This is string. Now, let's take the next program that is simply used to find the characters or how to find the square of a two numbers. For example, if I have to find the square of two numbers, that can also be done by using two operators. Yeah, that will be also done now. Let's see what is the uses of gets. That is how we are using the gets. We have covered all these topics, but we have not introduced the or we have not covered the practical approach. That's why I covered this practical approach. Suppose the same I have declared the one variable as a 20 or 30. Let's say example 20, right? Then there is a CLR, SCR over here. Then simply uses the printf, then uses the this one, that is enter the string. Then uses the gets for fetching the values. That is instead we have used the scanf, but here if this is a string, then I have to use the gets over here. That is gets ch. Now if I have to print the value by using the printf, that is simply uses entered string is this one. That is ch, right? Then simply uses the print get ch for printing the values. Now if I compile this code, that is a success. If I execute this code, enter the string. For example, if I enter the string as a flower, the entered string is flower. So this means the gets is also used, or gets are also used for printing the screen, or gets are also used for scanning into the memory, just like the as we done in the scanf. That means for that purpose, that is for numeric purpose, we use the printf, or sorry, scanf, but for string purpose we have to use, or we are using the gets. That is gets is similar to the scanf, that is used to store the data into the memory, right? So if I save this file, the example of this is gets, right? Now this program is clear to all of you? All right. So okay, thanks Larry. So I think I have to wind up this class at the same time, because I have to search the slides for the computer system in this laptop. So I have to stop this in the at that moment or this moment, because I have to see the slides for the computer system, because most of the students want the slides for the computer system. So let's stop over here only. If you have any doubts about anything in the C language, then you can ask from me. But in the meantime, when I stop this class, in the meantime, I started searching for your computer system slide so that you get benefit and you are able to cope up, or you are able to get the new concept of this one. So thanks a lot everyone for listening me. Now again I'm telling you, if there is any doubt you can ask from me. Thanks a lot everyone. Bye bye.